Pipes that operate under a wide range of loading conditions are going to expand and contract. There is no way around it. And unless there's some way for the pipe to give a little as it heats up and cools down, that pipe is going to weaken and eventually break. Now, in the last two segments, we looked at various ways of supporting pipes externally. We saw support structures as simple as saddle clamps and as complex as hydraulic and mechanical snubbers. Each of these components was attached to a pipe at one end and to some external support like a floor or a wall or an I-beam at the other end. Now, in this segment, we'll look at several components that are in line with the pipe. They're attached to the pipe at both ends, but allow the pipe to give a little as it heats up and cools down. Now, two of the most common of these components are expansion joints and expansion loops. Expansion joints allow for limited pipe movement up and down, side to side, and back and forth. They also reduce vibration. Generally, an expansion joint will either be one piece that flexes or two pieces, one of which slides inside the other. Now, this is a one-piece flexible expansion joint. The two pipe sections that it joins are here and here. The main part of the expansion joint is this rubber sleeve. It's often reinforced with cloth and wire to add strength. The whole assembly may be protected by a thin metal covering. The bulge here in the center is where expansion and contraction take place. If expansion joints like this fail, it's usually due to deterioration of the rubber. So when you inspect them, be sure to look for cracking or crazing of the rubber. A second type of expansion joint has two pieces or sleeves. One of the sleeves slides inside the other, allowing the pipe sections here to expand and contract. The sliding sleeve is kept from coming out of the stationary sleeve by this limit stop. Also, there's packing between the inner and outer sleeve to keep the fluid that's moving through the pipe from leaking out past the sleeves. New packing can be inserted through this packing plug. Finally, there's a lubrication fitting here. Several times a year, grease should be injected into the packing gland to make sure the sliding sleeve will be able to move easily. You should also check the sleeve occasionally for pitting and corrosion. Now, the other approach to letting a pipe give a little is to use an expansion loop. In this arrangement, the pipe itself is made into a long loop. As the pipe expands and contracts, the loop moves back and forth, compensating for the movement of the pipe. Now, during your periodic inspection of pipe hangers and supports, you should pay special attention to expansion loops. Since these loops may move more than other piping runs, their hangers and supports will receive more stress. Now, there's one more class of piping auxiliary that I think we should look at. Components that compensate for pressure changes in fluid systems. Whenever the smooth flow of fluid through a pipe is interrupted, the piping system will be jarred. When a fluid system is started up or shut down, or when water hammer occurs, the piping will take a beating unless it's protected. And two devices that offer protection against pressure shocks are the pneumatic surge dampener and the water hammer impact flange. A pneumatic surge dampener, or surge chamber, as it's sometimes called, is simply a metal tank with a rubber bag in it. The entire dampener is installed in line with the piping, as you see here. The rubber bag inside the dampener is usually filled with nitrogen gas. As the pressure of the fluid inside the pipe changes, the rubber bladder expands and contracts. The bag acts like a shock absorber to smooth out pressure fluctuations in the fluid. Water hammer impact flanges take care of a different kind of shock, one that occurs in steam lines. These flanges are designed to absorb the impact of a slug of water that would otherwise slam against the wall of a pipe. They're commonly found where there is a bend in the pipe. In this diagram, steam travels in this direction. If a slug of water were entrained in the steam, it could end up slamming into the wall of the pipe. This is called water hammer, and it can cause very serious damage to piping systems. One way to protect against water hammer is to extend a section of the pipe just downstream of a bend and install a water impact flange, like you see here. The flange consists of an orifice plate, a metal cone, and a second metal plate, all welded together. When steam and entrained water reach a bend in the pipe, the steam makes the turn easily, but the water, being denser and heavier than the steam, can't make the turn. It keeps going straight, hitting the orifice plate. The plate absorbs part of the impact, but some of the water passes through the hole in the orifice plate, hitting the metal cone and the second plate. Usually, they can absorb the rest of the impact. Sometimes, though, the impact will be so great that the cone and plate will break right off. And if this happens, the flange assembly must be removed and re-welded. Well, we've now seen several of the most common types of piping auxiliaries. We looked at strainers and filters and saw how they remove contaminants from fluid and air systems. We examined some of the ways that pipes are held in place. We looked at ways to allow for expansion and contraction in pipes. And finally, we looked at ways to absorb shocks to a pipe and within a pipe. There are even more piping components that you'll learn about in other units. Components like vacuum breakers and moisture separators. And even though some of this equipment may require only occasional maintenance, it's all vital to the operation of your plant. The day will come when one of these reliable components fails. And when that happens, a lot of people will be standing around waiting for you to fix it.